Okay, with unit conversions, the most important thing to have is the conversion factor, because the conversion factor relates to the two units that are involved, the unit that you want to convert from and the unit that you want to convert to. So I've listed here some common conversion factors. So 1 kilometer is 1,000 meters, 100 centimeters equals 1 meter, 1,000 grams equals 1 kilogram, 1 hour equals 3,600 seconds, and 1 minute equals 60 seconds. Then you also have the prefix table that we've learned in the lectures. You can find this in lecture slides of lecture 4. So for example, you are given, say, 20 micrometers. Okay. The prefix micro here tells us that you replace this symbol micro with 10 to the minus 6. So 20 micrometers essentially means 20 times 10 to the minus 6 meters. And so you have that conversion factor of 20 micrometers equals 20 times 10 to the minus 6 meters. So when you're converting between micrometer and meter, you use this prefix table to get the conversion factor. But usually the most common conversion factors I have highlighted here. Right, so let's look at an example and convert, say, 250 kilometers per hour, and we want to convert that to meters per second. So when you do unit conversions, I would suggest to separate the number from the units. So 250, we can separate that from the unit as being 1 hour, 1 kilometer divided by 1 hour. So we did not really change the equation because any number multiplied with 1 is the number of itself. And then any number divided by 1 is the number itself. So 250 times 1 is still 250. Divided by 1 is still 250. So this 250 times 1 kilometer divided by 1 hour is still 250 kilometers per hour. But the reason why we write it this way, so then we can use our conversion factor and replace the unit that we don't want. So here we don't want kilometers, we want meters, and we can see here from our conversion factor that 1 kilometer equals 1,000 meters. So we can now replace that 1 kilometer, replace that with 1,000 meters, and then we also want to replace hours with seconds, and we can see here the conversion factor 1 hour equals 3,600 seconds. So we now go and replace 1 hour with the seconds equivalent, and so this one will become 250 times 1,000 meters divided by 3,600 seconds. Right? So we can see our units are now in meters and seconds, which are the units that we like, that we need. So we go ahead and do the calculation, 250 times 1,000 divided by 3,600. And that will give us 69.4 meters per second. That's equal to 250 kilometers per hour. Okay, so essentially you need a conversion factor. Write the number, the thing that you want to convert in terms of number times the units. look at your conversion factor and replace the units that you don't want with the units that you want. Now let's look at a more complicated example where you have 7,800 grams per cubic centimeter, and we want to convert that to kilograms per cubic meter. So how many kilograms per cubic meter is 7,800 grams per cubic centimeters? Okay, so we do the same process. We write down the number separated from its units. So 7,800 times 1 gram divided by 1 centimeter times 1 centimeter times 1 centimeter. Okay. So centimeter cube means that there are 3 units of centimeters in a centimeter cube. And so we have 1, 2, 3 units of centimeters. Right? If, for example, you have, say, for example, centimeters squared, then that square, this exponent 2, means that you only have 2 units of centimeter present. So 1 centimeter times 1 centimeter is equal to centimeter squared. Right? Okay, so now we've written down our the thing we want to convert in terms of the number and the units. We now go to our conversion factor. Okay, so we can see here we want to change grams into kilograms. Okay, but notice our conversion factor says 1,000 grams. Okay, but in fact we want to change 1 gram. Here we want to replace 1 gram, not 1,000 grams. So we have to do something to this 1,000 grams in order to get 1 gram. Okay. And mathematically, the rule is that if you divide a number by itself, that will be equal to 1. So if I go ahead and divide 1,000 grams by 1,000, then that will give me 1 gram. Okay, but whatever you do on one side of the conversion factor, you have to do that on the other side of the conversion factor as well. So I've divided 1,000 grams by 1,000, so I should divide 1 kilograms by 1,000 as well. And as I've mentioned earlier, any number divided by itself is equal to 1. So 1,000 divided by 1,000, that's equal to 1. And then you have the gram. And then 1 divided by 1,000 is 1,000th. So 0.001 kilogram. Right? Okay, so we can now replace grams with kilograms. So 7,800 times 1 gram, our conversion factor, 1 gram is equal to 0.001 kilograms. Okay, now let's do the centimeters. So our conversion factor says 100 centimeters is equal to 1 meter. Okay, so conversion factor, so we want to convert centimeters, 1 centimeter times 1 centimeter times 1 centimeter. And our conversion factor is 100 centimeters is equal to 1 meter. So again, what we want is 1 centimeter, not 100 centimeters. So we need to do something in order to change 100 centimeters into 1 centimeter. So just like we did with the grams, if we divide 100 by itself, we'll get 1. But we have to divide the other side of the conversion factor by 100 as well. So 100 divided by 100, we have 1 centimeter. 1 divided by 100, we have 0.01 meter. So that's now our conversion factor relating 1 centimeter to meter. So we can now replace centimeters in this equation. So we have 7,800 times 0.001 kilograms divided by 1 centimeter is equal to 0.01 meter. But we have to do that 3 times because there are 3 units of centimeters that we need to convert. So we need to convert each of these centimeter units into meters. So you have 3 units of meters there. So you go ahead and do that in the calculator and you should get 7, 8, 2, 3, 5 zeros kilogram per cubic meter. All right. Okay, one of the issues being encountered here is the issue of bracketing in your calculator. So if you did not put a bracket, you will get the same 7,800. And you know intuitively that converting 7,800 grams per cubic centimeters cannot be equal to the same 7,800 kilograms per cubic meters. So what you should do when you enter this in your calculator is you put brackets. So 7,800 multiplied by, so you do go brackets. Let me just erase that because that looks like a negative. So what you do is you go bracket 7,800 times 0.001 divided by, you have to bracket the whole thing in below the denominator sign. 0.01 times 0.01 times 0.01. Okay, and you should get, yeah, that's 7,800,000. Yeah. Okay, so one other question that was asked was converting this to scientific notation. So if you have a whole number, an integer, the decimal point is not shown, but it's implied that it's at the end of the number. So in this 7,800,000, the decimal point is implied to be at the position after the last number. In scientific notation, you write the number in the form a times 10 to the b, where a is the value of a is anywhere from 1 to 9, and b is a positive or negative number equal to the number of steps taken to move the decimal point in order to get a. Right, so a should be between 1 to 9, so it can be from 1 to 9. So you have to move this decimal place to the left. until you get a number that is from 1 to 9. So you go 1, 2, 3, 4, 5, 6, 7. Oh, that's 1 2 zeros too many. I have 1 0 too many in my answer. Yeah. So we do 1 2 3 4 5 6. Yeah, so I just corrected myself there, because if you input this in the calculator, 7,800 times 0.001 divided by 0.01 times 0.01 times 0.01, it should actually be 7800000. So there should just be 5 zeros instead of 6. So I just corrected myself there. Yeah, so moving this decimal point to the left, you've moved 1 2 3 4 5 6. So 6 steps to the left in order to move that decimal point. Okay, so your number A in the scientific notation will therefore be 7.8. It's between one, yeah, it's from 1 to 9. And then your B is 6 steps. Right? And if you move to the left, B is positive. If moving to the left, if you move the decimal point to the left, and B is negative if moving to the right. Meaning if you move the decimal point to the right, then B will be negative. In this case, we move to the left, so B will be positive. And so our scientific notation, 7, 8, 1, 2, 3, 4, 5, that will be equal to 7.8 times 10 to the 6. So if it was a small number, so say 0.00025, for example, and you want to write that in scientific notation, okay, the decimal point is obvious now. Decimal point is here, but you need to move that decimal point to the right, okay, until you get a number from 1 to 9. So you go 1, 2, 3, 4, 5. Okay. So 5 steps to the right. So your A is equal to 2.5 and your B is equal to 5 steps, but you move to the right, so that will be a negative number. So in scientific notation, 0.1234025 is equal to 2.5 times 10 to the negative 5. So essentially, for converting, the most important thing you need is a conversion factor. Write your value in terms of number times the units, then use the conversion factor to replace the units that you don't want with the units that you want. And then finally, for scientific notation, you want to rewrite the number so that it's from 1 to 9, and you do that by moving the decimal place. The number of steps that you move the decimal place will give the power in the scientific notation. And if you move to the left, then that power is positive. If you move to the right, that power is negative.